is this relation a function? Does each x value match up with or point to exactly one y value? Right off the bat, you can see that 2 points to -3, and that same 2 points to 3. That x value of 2 has two different y values, so that's not a function. Is this relation a function? Does each x value match up with or point to or correspond to exactly one y value? Well, if you look at the x values, you have x values of -7, 9, 14, and 7. None of those repeat. So looking at this relation, this set of coordinates, none of those x values are the same. So each of those x values is matching up with or pointing to exactly one y value. Now what makes this confusing though is all these 14s and 7s, especially this, where you have two y values that are 14. And they have different x values. So you have a y value that has two different x values. That's perfectly fine. Remember the rule. You cannot have an x value that matches up with or points to two or more different y values. Each x value has to have exactly one y value. But you can have a y value that has two different x values. That's perfectly fine. It's still a function. So this is a function. Each x value has exactly one y value. It says which point could not be part of a function. That includes these points: 3, -1, 4, 2, 5, 4, -2, 0, and 8, -3. So what you're looking for is a repeating x value that has a different y value than what's shown here. So if you look at these answers, you have an x value of 6 and a y value of -7. Well, that would fit into this fine because there are no other x values that are 6. This letter G here, 3, -2, if you look at the points, you have a problem right here because this 3 matches up with -1, and this 3 would match up with -2. So if you have an x value of 3 matching up with or pointing to two different y values, then that would make that not a function. So that 3, -2 would throw that off, and it would not be part of a function with those other points. The 7, 4 would be fine because there is no other x value at 7. And the 2, 2 would be fine because there is no other x value that is 2. Got a -2, but not a +2. So 3, -2 would not be part of a function with those other points. Remember, for a relation or a set of ordered pairs or set of coordinates, however you want to phrase it, for that to be considered a function, each x value must match up with or point to or correspond with, whatever words you want to use, exactly one y value. So each x value must have exactly one y value for that set of ordered pairs, that set of points to be considered a function. You think about that graphically, your x-axis is horizontal, the y-axis is vertical. If you look at a graph and you look at the points on that graph, each x value on that graph must have exactly one y value for that to be considered a function. There's what's called the vertical line test. A vertical line test can be used to determine if a relation is a function. So let's say you have a graph. What the vertical line test does is that you imagine a vertical line passing through that graph. In fact, I'll bring one right now. You bring a vertical line through that graph. If that vertical line hits in more than one place as it is passing through, then that's not a function. Remember, if it's not a function, that means you have an x value that matches up with or points to two different y values. And in this particular graph, you have several of them. So if you have an x value that has two different y values, it's not a function. So each value of the domain must have exactly one value of the range it's matching up with. Or each input must have exactly one output. And like I said, this particular graph has several situations where an x value has more than one y value. One example we're sitting right now is at 4, 3, and 4, 5. You see the x value of 4 is matching up with 5 and also 3. So you have an x value matching up with two different y values. That is not a function. Just quickly going to go through some various examples of graphs, and you're going to decide, is it a function or not? Well, I guess I'm going to decide. A circle. Is that a function or not? Well, if you pass a vertical line through that circle, does it hit in more than one place? Yes, there are several places where that vertical line is hitting in more than one place. So in other words, you have an x value that would have two different y values. So that is not a function. If you have a diagonal line, would that be a function or not? Well, if you pass a vertical line through that, it's only going to hit in one place as it's passing through. So as that vertical line is passing through, it's only hitting in one place. It's not hitting in more than one place as it's passing through. That is a function. This graph, if you pass a vertical line through that, it's going to hit in more than one place as it's passing through. Now, down here at the very end of it, it only hits in one spot. But as it's passing through, you have x values that have two different y values, so that is not a function. Diagonal line going the other way. It's not going to be any different. You pass a vertical line through that. Doesn't matter which way you pass the vertical line through. It's only going to hit in one place as it's passing through. So that is a function. A function rule is an equation that represents an output value in terms of an input value. You can write a function rule in what's called function notation. You've seen these before. Y equals 3x plus 2. The y is the output, the x is the input. But that could be written a different way and still mean the same thing. You could write it like this. When you have f with parentheses and an x inside the parentheses, that's called function notation. That's pronounced f of x. So f of x equals 3x plus 2 is the same as y equals 3x plus 2. F of x and y are the same thing. So when you see f of x, when you see g of x, when you see h of x, those are the common ones. Those are the y values. Remember that. F of x, g of x, h of x, those are y values. You see something like this, f with parentheses and 1 on the inside of the parentheses. What that means is you're putting 1 in for x into that function. So we had f of x equals 3x plus 2. If we're looking at f of 1, that means we're substituting a 1 in for x. We're inputting 1 in for x. The output is going to be what f of 1 is, which is this side. 3 times 1 plus 2, which of course is 5. So the input would be 1, the output would be 5 in this case. Remember, the input is the x value, the output is the y value. Function notation, though, the common ones used are f of x, g of x, h of x. If you see those, remember that's the y value. Some other words you should remember or learn if you didn't know them. The independent variable. That's the x value. Think about back to Algebra 1. When you made your charts with x on the left and y on the right, I had one up here earlier. With x on the left and y on the right. How did you get those x values on the left? Where did they come from? You made them up, or you put them in, or your teacher may have told you what numbers to put in. They were independent. They could be whatever you wanted them to be. So the independent variable is the x. Well, how about numbers on the other side of that chart, the y values? Where did those come from? Those were the output. The numbers that you put in for x produced that output. They were dependent on what x was. So the output is dependent upon the input, or the y value depends on what x is. So some words you do have to remember. Independent variable. That's the x, also known as the input. When you're talking about a collection of x values, that's known as the domain. Dependent variable, also known as f of x or y. That's the output. The collection of y values is known as the range. So independent variable is the input, dependent variable is the output. You can relate that to if you play sports. Your output or your performance is dependent upon, so that's the Y value, that's the dependent variable. That performance in games or that output is dependent upon your input, the practice time you put in or the work you do at home. So the independent variable would be your practice time or your work. The dependent variable would be your performance or your games. So back to this, the independent variable is x, also known as the input. The dependent variable is the y or f of x or g of x or h of x, also known as the output.